Good afternoon, ladies and gentlemen of Algebra 2 Honors. Good to see everybody here. Except for Connor. Maybe he'll join us by video later. But whatever it is, we are it, right? We're going to go over these different problems. And I encourage you to be open-minded about it. I've had some really good discussions during second and seventh period, just because people are open-minded, ready just to consider different techniques. So if you can kind of bring those, they can be quite helpful today. So problem one is solve the polynomial equation by factoring. So what would you look at as maybe possible techniques or approaches to problem one? So Addie says factor out x. Do you agree? You see why she wants to do that? Do you? Okay. Well, this is really good. See what happened is what Addie just said. I was able to say that today. See, she just said it. I had to threaten to flunk people back to Algebra 1. But not this class, not today, because of Addie. Do you feel good about not being threatened to be flunked back to Algebra 1?
I do.
Okay, really good. Well, we appreciate that. Now what happens is, in all seriousness, things can be a little fuzzy, right? We lose little things and not put everything together. But how do we go ahead and start out doing this, Addie, do you think?
Factor out the x, so x and then times 6x squared minus 13x minus 5.
Okay, very good. So have we already solved part of this equation? Yeah, x is going to be equal to what? How about my muscle men back there? X is going to be equal to what?
And not equal?
Equals. X is equal to 0, guys.
That's what I was going to say.
That's fine. That's fine. We're working on this together. I haven't had to even consider flunking anybody back to Algebra 1 today, so I already feel good about that. Okay, what would be a next phase to go through this, I guess I should say?
To factor the trinomial?
Okay, Ben says factor the trinomial, right? So let's see if we can do that. So something like this, Ben, you think? Okay, and so how would you do that, or what technique would you use, or how would you approach that? Or anybody else, somebody besides Ben too.
I'll use that x method.
Okay, Ben suggests maybe doing an X method. All right, so what's going to go here in our X?
You see goes on top, so it's
AC? Is it AC?
AC, right? AC, negative 30, right, Marcus? All right, I'm going along with Marcus on this one here. And then what goes down here? Negative 13. All right.
And then is it multiply together to get?
Multiply and then add together. So you got to multiply and add together in the right combination here.
Are we trying to multiply to get negative 30 or negative?
Multiply to get negative 30? No, it's the other way around.
No.
Then what is it then?
Well, two negative numbers can't equal a negative number. Multiply together can't equal a negative number.
Okay.
It would be negative 15 and positive 2.
Negative 15, who said that for us?
Mark.
Marcus?
Yes, I.
Yeah, okay, Marcus, negative 15, positive 2, let's try that. Let's see if that, let's kind of backtrack, see if it works out. Multiply them together, negative 30, check. Add together, negative 13, check. That's good, right? All right, that's real good. So now what are we going to do with this thing?
Divide by A.
Divided by A, which is 6. So here we get 1/3. And here we get, so that's going to be negative 5/2. Something like that. Does that look good, Marcus? Does that look right?
Yeah.
Okay, good. So now so really we have something we can work with now. We can go to x minus 5/2, and we can go to x plus 1/3. And then when we use our bottoms upping method, what do we get for this?
2x minus 5.
2x minus 5. And then we have 3x plus 1. Okay, so we already know x is 0. What else is x equal to here? X is equal to? It's 2.5, somebody said 2.5. Yeah, let's see, let's say 5/2, right?
Oh, so 5/2 and 3?
1/3.
I'm getting negative 1/3 over here is what I get. Okay? And so now we have 3 solutions, and we can do a test. Now we haven't gone to a calculator yet, but that can be done, right? So we come here and say, okay, that's going to be, what did we say it was? 6x cubed minus 13x squared. Okay, 6x cubed. Okay, 6x cubed minus 13x squared minus 5x, was it?
Yes.
Just kind of see what that looks like. Looks like we have that 0. Looks like we have that 5/2 going on here. Negative 1/3. And we can test different values in our windows if we want to go ahead and take, if we want to test this like right here. We can delta start at 0 maybe. We should be able to see a 0 right here where x equals, where x equals negative 1/3, right? You can try different things like this. You can try you can try 2.5. Okay, same sort of thing. Test our 0, right?
Right.
Works perfectly, doesn't it? So anyway, this will be our answer right here. Here we go. So these will be our answers, okay? All checked and double checked and triple checked and quadruple checked. Something like that.
Check.
Okay, good. What I want to do is look at problem 2. Same sort of thing. You can look at it, see what you think. We'll talk about it in about 2 minutes.
I don't know because I don't know if that's right. Negative 6 is our rule. Bottoms up. I mean, not bottoms up, but
So now,
after this,
the
what
rule
do you
is
do?
0x has 0. That's one thing.
Where is 0 divided by? Why are you divided by 2?
Because if you look at this equals 0, so x could be 0.
Then it actually is. Yeah.
So then you have to go into the bottom.
You don't get, you divide by 8.
So this? Yeah.
How did you get it? Maybe I'm. Did you get it? You know, hey, y'all want number 2, right? Yes. Yeah, I got x equals 0, x equals 30, x equals 6. Oh, your daddy was right. What I do? I don't know what I do. Oh, I didn't divide by A. Why are you? I didn't divide by A. Yeah, I don't know. Maybe if we pull out 2x. Time to start over. Don't call on me.
Yeah, that happens. I know what that's like. Have to start over.
It's going to be split up again.
Okay, guys, you get it now? 2x times 5x.
All of the x
Plus 3.
Good.
Good, now I have to erase this x.
Okay, good. Let's see if someone has an idea. I'm gonna really. I'm gonna choose somebody here from our tabulator. It'll be Julia. Julia, do you have any ideas on this one?
I factored it out.
Okay, let's go ahead and tell us what you have, Julia.
X parentheses 4x minus 10x plus 6.
X parentheses
4x
4x
plus minus 10x plus 6.
Does that look right?
Okay, you can factor out the 2. Oh, I meant squared, sorry.
What here?
On the first one?
Like that?
Yeah.
Okay, anything else that's factorable out here?
Can you factor 2?
2, right?
2x.
So 2x, that'd be times 2x squared minus 5x plus 3, is that right? Does that look right? That's right, isn't it? Okay, looks good. So what else solved by factoring do we have here? Did most people get to this point here?
Yes.
Jay figured it all out. He did the box.
Oh, Jay, you did?
Yeah, he's pretty smart. He went James. Sorry. Yeah.
When I was working with the 7th grade class, I was getting a little confused on the box method on this thing. That's just me.
The X method confuses
The
me.
box method, yeah, makes no sense to me.
It does not?
It does.
Oh, it does make sense to you? Yeah. So, yeah, so, anyway, I guess I'll call on somebody else in this one. So it sounds like people are ready.
Yeah, Jay, it's on Jay already.
I think you should just call him Jim.
Oh my gosh.
Addie.
Big Addy.
So Addie.
Mr. G.
All right, Addy, what did you have for this one?
I tried to do the X method, and I have,
Okay, let's do that then, right? Try, so this one's gonna be, what is it, 6?
6, and
-5,
yeah.
okay.
And I have -3 and -2.
-3, -2. Now, certainly they will add together, but let's see. Now they would add together to get that, but multiply to get that. Does that look right? Okay, so let's see here, -5. Okay, yes, let's go ahead. Then we have
Then divided by 2.
2. So here we have -1, right? So here we have 2x. We got x -1, and we got x -3/2, right?
Yeah.
So what is this going to be here?
And then that's where I kind of stopped. I have 2x minus 3,
2x -3, okay.
and that's where I stopped.
So you're stuck here, okay. So here we have x is equal to 0, x is equal to 1, and x is equal to
3 over 2.
3 over 2. Does that look right?
You did that, Brett. That's all I got.
Okay, 4x cubed minus 10x squared plus 6x, take a look.
You had it right there, you just. It's not
I
so
didn't
good.
finish up.
I mean, the right answer would be, it just wouldn't be simplified on it.
The one time I was right,
That's going to be plus 6x.
Hey, Connor, come here. You just got called, huh?
Dang,
So here we have it. And we should have 0 and 1 and 1.5. Does that look right?
Yes.
I think it does look right.
Yeah, that looks right.
You gotta talk on your story now, because he wasn't here
So
for
for
it.
your story.
Yeah.
Yeah, my wife got COVID, and I got COVID 2 days later,
So, wait.
so I've had to recover these past several days
Before this one.
until Mr. Collins let me come back. That was nice of him to let me come back. Okay, any questions on this? Good work. Thank you for your good work. Let's go on to number 3. Okay, number 3. Number 3 is just kind of a vocabulary assemblage. So relating the title of a type of function and how many at most x-intercepts will be produced by potentially that type of function. So for this first one here, we have a quadratic function has at most how many x-intercepts? Okay, J, cannot see Jay on camera, but he is pointing up 2 fingers, right? So 2 x-intercepts. All right, does everybody see how that could happen? Yeah, Julia is saying, yeah, so you take some, it could look something like this, right?
Yeah.
Okay, good. A cubic function has at most how many x-intercepts? 3. Okay, this would be 3. A quartic function has at most how many x-intercepts?
I'm gonna say 4.
Okay, Jay is also saying 4. Yes, that is right, 4. A quintic function has at most how many x-intercepts?
I'm gonna say 5.
5. And what that would look like potentially, a quintic function would look something like this. 1 x-intercept, 2, 3, 4, 5. So that would be like a possible quintic function with 5 x-intercepts. Okay? Lastly, linear function has at most how many x-intercepts? 1. Okay, Bryce says 1. Bryce. The Bryce is right. You ever heard the Price is Right? In this class we have the Bryce is right. Nobody laughed at that. I thought that was funny. You did? Okay, good. I'm glad you laughed. The Bryce is right. Man, that is really genius. Okay, let's go on to number 4. What are the roots of the following equation? So we're given an equation, and we want to find out how many roots we have here, or what they are. What are all the roots of that following equation?
Depends on what kind of food it is.
What would be your theory? I don't know if our muscle men have a theory on this one.
Well, equals 0.
What did you say?
X equals 0.
X equals 0. How'd you get 0?
Put the numbers, and
It says
I've also put 0.
Because X is 0, 0 minus 0 plus 0 equals 0.
Yeah, so 0 minus 0 minus 0. So X is equal to 0.
That's one of them, right? What was that?
Without X equals 0. So X equal to 0
One
is going to be one of our roots of this, right?
Right.
X equals 1.
Okay. What else can you do to find roots for this thing?
I think Kim thinks like she knows.
Oh, yeah.
I did not know.
You can't laugh at my answer if you don't have one.
Like
Yeah, what's the answer, huh? Yeah.
Okay, I want to show you a little technique on this one. And it really is similar to what Ben was talking about. What you can do is you look for your greatest common factor, and you can take x squared out here. So then you have x to the third, and you have minus x squared. You have minus x and plus 1. And if you set that equal to 0, you have x squared equals 0, right? So we call this as x squared equals 0 with multiplicity equals 2. Okay, because we have x squared. All right. So what else is another brilliant scheme somewhere percolating in that mind? 1, you say? X equals 1?
Yeah, X equals 1. That's what Kim was laughing at me about.
Okay, well, it's probably worthy of being laughed at. Just kidding. Just having some fun in class. All right, so Ben is saying, right, 1, then 1, -1, -1, 1, right? So what is this going to be? It's going to be 1,
1 times 1 is
1, 0. That's 0. Negative 1. Negative 1. That's going to be 0, right? So we have, what we have is, our answer is going to be definitely x squared. Plus we have that, so we're going to have x minus 1. And then we're going to have, this is going to be x squared minus 1. Okay? So we're closer to having fully factored, right? What are your other, can you factor this any further?
I'm gonna say yes, but I don't know how.
You don't know how?
'Cause
It's called difference of squares, guys, difference of squares, you know this one. Okay, it's this. We got x squared, we got x minus 1, and then here's our difference of squares right here. We got x minus 1, x plus 1. Right? This is our difference of squares. So now we're left with x squared, and this thing is squared here. So the x minus 1 squared times x plus 1. So really the roots are x equals 0, x equals 1, which is a double root, x equals negative 1. Right? So x equals 0, x is equal to 1, that's a multiplicity of 2. And finally x equals negative 1, which is multiplicity of equals 1. Okay? That's it. What I want to do today is kind of finish with number 5. Kind of look at number 5, just kind of see what's happening there. All right? Does number 5 look like any of the others we factored so far today? Not much, right? It looks different somehow.
There's no x cubed.
Yeah, there's no x cubed.
This is 4x per car.
I was reading.
Hi, good afternoon. You are Addie, whatever you're taking, I need to be taking. What are you taking?
Nothing.
Nothing. You're just high on life, is that?
It's on the oxygen. That's not life. It's on that oxygen in the air, right? It's on the oxygen.
Oxygen in here? Yeah, we have good oxygenization level in here. Must be. And Kim, sometimes she just has too much fun in this class. I don't know what makes it happen, but I'm glad you are having fun in class.
I'm not.
I'm gonna go with one of the
I just looked at you.
And you laughed at my answer and called me stupid. The answer was right.
That's mean. Mr. G, I'm not gonna be here tomorrow either.
Oh, you're not? Baseball again?
Hey, that's not a promise.
Oh, track? Okay. Well, try to keep up with the videos and so forth. We have these, because that's one reason I'm trying to drag this out a few days, give us a lot of class time. Any ideas on this one, number 5?
Synthetically divided?
Synthetically divide? Okay, what would be your choice for that?
Still thinking on that? Probably 2.
2?
Ooh, that's smart. It's gonna be tricky there for me.
So here we have 1, 0, negative 18, 0, 21, right? Is equal to 32.
30.
And you said 2?
Yes.
Okay, let's try 1, 2, 2. Be 4, right? Negative 14. And then 2 times negative 14 would be negative 28. And then we get negative 4 here. And we get,
What?
8.
Negative 28.
that should be negative 28, right? Should be negative 28. Yep, let me get that, let me fix that. I'm sort of working ahead too fast.
It's not.
It's not, hey, it's not due.
Yeah.
And then we have 2 times negative 28 be negative 56, right?
Yeah.
So that's not going to work out for us, is it?
No.
So let's go ahead, we'll try something else. Okay, 1, bring down the 1, 1, 1, 1, 1, 1 times 1, 1, that'd be negative 17, right? And then we have negative 17 here, and negative 17 times 1 is negative 17, and we'll get 15 here. Is that going to work for us?
No.
No. What else?
About 30.
Let me suggest here something.
Mr. B suggesting.
What?
No, I'm saying you.
What if we try 4?
That's what I was just telling him, but he was like, no, like, it's not possible yet.
So here's 4 here. Then we have, add these together, we get 4. 4 times 4, 16. Negative 2 here. And we get 4 times negative 2 is going to be negative 8.
Negative 8.
And we bring negative 8 here. Oops. And we multiply these together, we get negative 32. Is this going to work out? Yeah, so we get, what we're going to get is x minus 4. And we're going to get x cubed plus 4 x squared minus 2x minus 8. All right? Any other ideas?
Wait, Mr. B, I can do
How about negative 4?
it.
1, 4, negative 2, negative 8. So now bring this 1. Negative 4 times 1. Negative 4, 0. Negative 4 times 0, 0. Negative 2. Negative 4 times negative 2 is 8. So we have x minus 4, x plus 4, and then we have x squared minus 2. And what is this going to be? So we get x plus square root of 2, x minus square root of 2. And so that's going to be it. Those will be our real roots. I want to show you something really quick on this. That one thing you can do is, it may not occur to you on this, but you can use a box method on this. You can take x to the 4th here, and you can take 32 down here. And so you'll have x squared times x squared. And then what are your factors of 32 going to be? 4 and 8. You can try 16 and 2. Let's try 16 and 2. And so what we get is we get 2x squared, and we get 16x squared right here. So what we have here is, that's going to be negative, so we've got to make these negative, right? So what we have is x squared minus 16 is equal to 0, and we have x squared minus 2 is equal to 0. And so you go ahead and take your factoring here. We have x is equal to plus or minus 4, and we have x is equal to plus or minus square root of 2. Okay, so a box method can work pretty quickly on this, if you understand what you're looking at, which to me it's not easy to look at it and figure it out. You got a calculator? Use your calculator. Ladies and gentlemen, we go ahead and resume tomorrow. I appreciate you guys staying to the end. I appreciate the laughing to the end. That was really some really good touch on the class today.
And then